Okay, we're going to be given a graph of the tangent function. Now, the tangent function is something different than we've seen before. We saw the sine, we saw the cosine. Now we're seeing a video with the tangent function. So we have the y-axis, y equals tan x, and the x-axis. And, of course, it's going to go on to the left and right infinitely, but we're just going to do it from negative 3 pi over 2 to positive 3 pi over 2, just for demonstration purposes. So you see we have multiples of pi over 2 listed here. We have negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2. And what's interesting here is we have asymptotes, vertical asymptotes in the graph of the tangent function. They occur at negative 3 pi over 2 on the x-axis, negative pi over 2, and 3 pi over 2. Now, they don't occur at 0. That's just the y-axis. So we have vertical asymptotes, the four that I've drawn here with dotted lines. Let me label them as vertical asymptotes, and I'll point to each of them. The asymptotes are here, 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 and here. So vertical asymptotes. And so they actually occur infinitely. They occur at x equals pi over 2 plus n times pi, for n being any positive or negative whole number or 0. So you could actually test that formula that I wrote down. And let's say n is equal to 0. When n is equal to 0, x is equal to pi over 2. We've drawn that one. It goes right through pi over 2 on the x-axis. When x is equal to 1, we have pi over 2 plus 1 times pi. 1 times pi is the same as 2 pi over 2, so we have x equals 3 pi over 2. We've drawn that one. On the left side of the y-axis, if you let n equal negative 1, you have pi over 2 minus pi, which is the same as pi over 2 minus 2 pi over 2, which is negative pi over 2, which we've drawn, etc. So you see, that's just a way to describe all the infinitely many asymptotes, which I've only drawn a few of, and I put the little little bubbles on each end to indicate that it goes on forever in both directions. Now, this is what they want us to find. The new asymptotes and the new zeros for a function they're going to give us. And they want us to write, the solution would be to write the given function in y equals a. Okay, well, they're going to give us a new function, and they want us to find the new asymptotes and the new zeros. And so the first step would be to make sure that we write the function in the form y equals a times the tangent parenthesis k times x minus b plus c. And then identify the a, k, b, and c. So we don't even know what the given function is yet. We just have the old graph of the old tangent function. But when we see the new one, we're going to write it in this form and identify the values for a, k, b, and c. Then the new vertical asymptotes. The new vertical asymptotes for the new graph will be the values x new equals x old divided by k plus b. Those will be our new asymptotes, the equations of these vertical lines, x equals a number. And then to find the new zeros, where they cross the graph crosses the x-axis, we are going to have x new equals x old plus b over k plus b. Okay, so let's test this idea of finding the new vertical asymptotes and the new zeros. Okay, so let's find the new vertical asymptotes for y equals a tangent of parenthesis 2x plus pi over 2. First, we have to get it in the proper form, so we'll rewrite it as, let's see here. First, it's given as 2x minus pi over 2. To get it in the new form, a tangent k x minus b plus c, we write 1 times tangent times 2. We pull out the 2. Pull out the 2. If you pull out the 2, you have parentheses. Now, you might not believe that. What's that pi over 4 you're saying? 2 times pi over 4 is pi over 2. So that's where it came from. We factored a 2 out of both of those terms, plus 0 at the end. So that's compared to a times tangent k parenthesis x minus b plus c at the end. So a is equal to 1, and k is equal to 2, b is pi over 4, and c is 0. So it's easy now to find our old values. Our old asymptotes, x old, were from the graph, you see, from the picture I've done up there of the asymptotes for tangent. I didn't do the graph of tangent, I just did the asymptotes. The vertical asymptotes occur at x equals, let's see, negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. They're actual equations. X equal each of these numbers gives you the equation of vertical lines, which are vertical asymptotes, so the graph doesn't cross. So our new vertical asymptotes are required by the formula that we just talked about. X new equals X old divided by K plus B. So it's going to be X new equals X old divided by 2, our K value, plus pi over 4, our B value. So let's do that to each of those values and see what we get. Negative 3 pi over 2 plus 1/2. Oh, we have to divide it by what? We multiply by 1/2 because that's the same as dividing by 2. And then we have to add the B value, pi over 4. Okay, take the next X value in the list. The old X vertical asymptote was negative pi over 2. So take that negative pi over 2, divide it by 2, or multiply it by 1/2, same thing. Add pi over 4, and then do the same thing to the other two. Divide them by 2 and add pi over 4. Divide it by 2, add pi over 4. Simplify to get negative 3 pi over 4. That's what we get when we multiply top times top over bottom times bottom, plus the pi over 4. Bring that down. Then top times top over bottom times bottom, negative pi over 4 plus pi over 4. Pi over 4 plus pi over 4. 3 pi over 4 plus pi over 4, etc. Okay? Now, continue simplifying. We get negative pi over 2, 0, pi over 2, pi. Those are our new vertical asymptotes. X equals negative pi over 2, X equals 0, X equals pi over 2, and X equals pi. And of course there are more, but I just made a list of the ones of interest to us here. So this is a method that you would use to find your new vertical asymptotes. We haven't talked about finding the new zeros yet, but that's how you would find the new vertical asymptotes. It's X new equals X old divided by the K value plus B. I'm sorry, those are the new zeros. The new asymptotes are X old divided by K plus. Oh, it's the same thing. Oh my goodness, didn't even notice that. It's exactly the same procedure to find the new vertical asymptotes and the new zeros. You just start with a different old value each time.